In this session, we're going to solve more interesting linear equations. More interesting because there are more steps involved. We're going to go over a four-step process that will work for most linear equations that we're going to encounter. The first step is to simplify each side individually. What that means is distributing to clear parentheses, collecting like terms, that sort of thing. We might also consider clearing fractions and decimals in this step. The second step is to add and subtract. The goal here would be to get the variables on one side and the numbers on the other side. The third step is to multiply or divide to get the variable all by itself. Now you'll notice that the second and third steps are kind of backwards from the order of operations. Recall that the order of operations is for expressions, and these two steps get kind of switched when we're solving equations. The fourth step is to check our solution. A lot of times we'd rather skip this step, but it's good practice. Let's get started. For our first equation, we have 4 times the quantity of y minus 1/2 minus 2y is equal to 6 times 5 minus y. Now, considering our four-step process, for our first step, to simplify each side, we're going to start with distributing to clear the parentheses. When I do that, I get 4y minus 2 minus 2y is equal to 30 minus 6y. Collecting like terms means we're going to perform the subtraction 4y minus 2y. And so on the left-hand side, we have 2y minus 2 is equal to 30 minus 6y. Now we're at the step where I want to add or subtract to get the variables on one side and numbers on the other. And so I'm going to add 6y to both sides and end up with 8y minus 2 is equal to 30. And finally, I'm going to add 2 to both sides. This will isolate the variable term. We have 8y is equal to 32. And then when I divide both sides by 8, we end up with a solution of y is equal to 4. It's good practice to check our solution, and to do that, what we would do is take that value of 4 and substitute it in the original equation wherever we see the variable we're solving for. I leave it to you to perform that check, and after you've done that, you'll be convinced that our solution is y is equal to 4. Our next equation is 5 times the quantity of x plus 3 plus 9 is equal to negative 2 times the quantity of x minus 2 minus 1. I'd like for you to pause the video and try this one on your own. For our first step, we're going to distribute on both sides, and so 5 times the quantity of x minus 3 gives me 5x plus 15. Plus 9 was already there. Negative 2 times x would be negative 2x, and negative 2 times negative 2 is going to be a positive 4. Minus 1 was already there. Now we're going to collect our like terms on the left-hand side. That'll give me 5x plus 24. And we're also going to collect our like terms on the right-hand side. And so we have negative 2x plus 3. Now we're at the step where I want to add and subtract to get the variables on one side. In this case, that means adding 2x to both sides to get 7x plus 24 is equal to 3. Now I'm going to subtract 24 from both sides to get 7x is equal to negative 21. And finally, divide both sides by 7 and end up with a final solution of x equals negative 3. You should take the time to check your solution. Our next equation has fractions in it. 2/3 y plus 1/2 times the quantity of y minus 5 is equal to y plus 1 over 4. Now I want to clear the fractions in this equation, and so the first thing that I need to straighten out is the least common denominator. Since our denominators are 3, 2, and 4, our least common denominator is going to be 12. Now I'd like to highlight a pitfall that I see when people try to clear fractions in a situation like this. We know that we're going to multiply each term by 12 to clear the fractions. You'll see that I've written the 12 3 times, and that's because the 2/3 y is a term, the 1/2 times y minus 5 is a term, and the y plus 1 over 4 is also a term. Each term gets one factor of 12 as I've written it, and I'm emphasizing that in the second term on the left-hand side, the 12 times the 1/2 is going to become 6. Once we have that as 6, then we're going to distribute the 6. And a lot of times people will multiply the 12 by the 1/2, and then they'll multiply the y minus 5 by the 12. But if we keep in mind how many terms we have, we can avoid that pitfall. Well, performing the multiplication, we have 3 dividing into 12 4 times. And so the first term is 8y. 2 divides into 12 6 times, and so we have that 6 that we talked about a moment ago, times the quantity of y minus 5 is equal to, and on the right hand side, the 4 divides into the 12 3 times, so I'm going to put the y plus 1 that was in the numerator in parentheses because it was more than one term, so we should distribute that 3. At this point, we're going to distribute in both sets of parentheses here, and so 8y plus 6y minus 30 is equal to 3y plus 3. Now I have like terms on the left hand side, 8y and 6y, they add to 14y, and we have minus 30 is equal to 3y plus 3. Now I'm going to subtract 3y from both sides. We'll end up with 11y minus 30 is equal to 3. I'm going to add 30 to both sides. Take the equation over here. We have 11y is equal to 33. And finally, I'm going to divide both sides by 11 to end up with the answer y is equal to 3. In our next equation, we have some decimals. Now we could take this as it is, just deal with the decimals, but I'll show you how to clear the decimals. We're going to multiply each term by 100 because we need to move the decimal point 2 places to make sure that the numbers that have the most decimal places become whole numbers. So each term is going to get a factor of 100. I'm going to use parentheses so I don't confuse it with the decimal point. It's useful to write the 100 for each term so we don't lose what we're multiplying by, and we make sure we multiply each term. After multiplying, we end up with 36z minus 50, remember we're moving that decimal point 2 places, is equal to 16z plus 30. Now I'm going to subtract 16z from both sides. We get 20z minus 50 is equal to 30. I'm going to add 50 to both sides, getting the variable term by itself. 20z is equal to 80. And finally, I'm going to divide both sides by 20 to end up with the final answer of z is equal to 4. Our last equation also has some decimals in it, And here we're looking at terms again. So I notice on the left-hand side I have two terms, those being 12 hundredths times x and 20 hundredths times the quantity of 4 minus x. On the right-hand side I have one term that's 6 tenths. Each term will get a factor of 100, and I'll write that like this up here, and here we've got 100. Now in the first term it's pretty clear we're going to have 12x. In that second term we're going to multiply the 100 by the 20 hundredths. That'll leave us with 20, and since it's only one term we do not then multiply the parentheses by the 100. On the right hand side 6 tenths times 100 gives us 60. Now I'm going to distribute inside the parentheses. To finish simplifying both sides of the equation, we have 12x plus 80 minus 20x is equal to 60. Now I'll collect the like terms on the left hand side. We have negative 8x plus 80 is equal to 60. I'm going to subtract 80 from both sides. Negative 8x is equal to negative 20. And then finally we're going to divide by negative 8. After reducing, we end up with x is equal to 2.5. At this point I'd like to highlight another pitfall. A lot of times when people are dividing in this step here by negative 8, they'll forget to write the fraction bar. What this ends up looking like, if I can go to the next page, is we had negative 8x is equal to negative 20, and when people make the mistake of forgetting the fraction bar, they'll write the negative 8 on both sides, intending to divide on the left-hand side, and what they ultimately end up doing is subtracting on the right-hand side. Make sure you use your fraction bar and avoid that mistake, and end up with the answer of x equals 2.5.